All right, moving on to the next page, we have looks like we're done with this test. Yeah? And we are moving on to a different test, which is unbalanced force test. So here we go. We want to know the net force that this car feels if it's accelerating. So we're going to use V equals AT plus V naught to get the acceleration. And that's going to be 60 equals A times 10 plus 40. And we're going to get that A is 2 meters per second squared. And so F, the net force, equals MA, which is going to work out to 2,000 newtons when we plug in 1,000 times 2. Now, if the coefficient of friction is 0.4, we went out of the force of friction. So we know that friction is mu times normal force. The car is like on the ground like this, so we're going to assume that the only forces we have are normal and weight, which means the normal force is equal to the weight, which is going to be 1,000 times 9.8, which is going to be 9,800 newtons, because that's 9.8 g times m, which is 1,000. And so F equals mu n is going to end up giving us 0.4 times 9,800, which works out to about 3,920 newtons. Now, we want to know the engine force necessary to get the car accelerating mu k equals 0.4. So what we need is we need a force that can actually overcome friction, which means that to just barely get over balancing the applied force here of the engine and the friction force going backwards balance when we're just on the verge of accelerating, which is what we ask in problem number 3. So, number 4, student gives his backpack a quick final push, then lets go, sending his backpack sliding across the table. So let's figure out what the stopping distance is based on what's happening with this backpack. So we have a friction force, a normal, and a weight. So we know that the negative friction force slowing it down is what makes the backpack accelerate. That's the net force. And so we are going to get that negative 6 equals m2 times a. So my acceleration is 3 meters per second squared. Now we need to know the stopping distance. To do that, we're going to get v squared equals v naught squared plus 2a delta x. And delta x is what we're solving for. I end up at a speed of 0, starting from a speed of 6, which I square, gives me 36, times 2 times negative 6 times delta x. So when I go ahead and solve, I'm going to end up getting a distance of 3 meters. Finally, if you have a rough surface, just to put this out there, mu static for a rough surface is 0.8. They ask us what it is for a smooth surface, and that's 0.2. So mu small means smooth. Okay. U large means rough. All right, so that's it for the first page of the second part of our review.